Hello students, how are you all? Welcome back to Akshar IIT Foundation classes, class 6. So students, I am your chemistry faculty, S. Mohan. Today I am going to start a second chapter of volume 2. In the 6th class IIT Foundation course, the second chapter of volume 2 is nature of matter. Nature of matter. So students, here today we are going to discuss about the matter. Okay. Now let's see now matter. What is matter? Yes. Very good. Matter means what? Anything that has mass and occupies space is called matter. Anything which has mass and occupies space is called matter. For example, here I have a pen. Is this pen a matter? Yes, because see, it has some mass, right? And it's occupying some space now, right? So it's occupying some space. So which has a mass and occupy the space is called matter. For example, if I take a duster, can you see this duster? This is a duster. Can you call it as a mass? Yes, of course. Why? Because it has a mass, and occupying some space, occupying this space. So this is a matter. Right. Now, for example, your book is there. Okay. Is that a matter? Yes. Book also has a mass and occupying some space. Of course, that's a matter. This whiteboard is there. Is this a matter? Yes. That's also matter. So students, which has a mass and occupy the space is called a matter. Now once you check around you once, okay, turn around here in your classroom and see whatever the materials are there, and you classify and you say that whether they are a matter or not. Here I have an electric bulb. Is it a matter? Yes, it's a matter. Here I have an AC. Yes, this is also a matter. So students, anything which has a mass and occupy the space is called as a matter. Right? Whatever you see around you, that all comes under a matter. Okay? Ciao. Now, for example, air. Okay? Air. Can you see the air? No, you can't see the air. Air is invisible. Can you see them? Can you say it as, is it a matter? Yes, this is a matter. Air we can't see, but still it is a matter because air has a mass and occupy the space. Yes or no? For example, if you take the balloon and blow the air in that balloon, okay? So what happens? The balloon bulges, means it becomes big. The meaning is what? It's occupying some space, right? So here, and air has a mass and occupy the space, so air is a matter. Now, here light, not bulb I am telling, light, okay? You can see in presence of light only. If there is no light, you can't see, right? Can you say the light is a matter? No, light is not a matter. Why? Because light do not has a mass and it's not occupying the space. Sound? No, this is also not a matter, it's not occupying the space. So, and for example, if you walk under the sun, then you can see a shadow. Can you see a shadow? Shadow. Okay. Here also, can you see my shadow is there on the whiteboard, right? Can you see the shadow on whiteboard? Yes. Is that shadow is a matter? No. You can see it, but it do not have any mass and it do not occupy any space. So this is not a matter. Is this clear, students? So matter means what? Which has mass and occupy the space is called the matter. Is this clear to you? So I'll write the definition of matter. So here, matter. Anything that has a mass and occupies space is called matter. If they ask you what are the characteristics of matter, you can say the same thing. Okay, matter has a mass. This is one character. Matter occupies space. There's also matter character. One more character. Any matter is made up of a tiny particles called atoms. Any matter is made up of tiny particles called atoms or molecules. Okay. For example, this pen is there. So this is made up of some atoms or molecules, right? So these three properties you can write. All matter is composed of particles. Any matter is made up of particles. All material bodies have a weight and hence has a mass, and all material occupy the space. Okay, so this is about the matter. Right. Now, classification of matter. Okay. Now let's see the classification. How you classify the matter? So, matter can be classified based on two things. Okay. One is on physical state. Physical state. Okay. And the second one is based on chemical properties or chemical composition. Okay. Chemical properties, or you can write chemical composition. Right. So, physical state. Physical means what? How? Okay. It appears. Okay, that's called physical. So, based on the physical state, the matter is classified into mainly three types, but in your material they discussed about the 5 types. Okay, so let us take the solids. Okay, let's take the liquids. Okay, and gases. You know these three, I hope. Apart from this one, we have one is called plasma, right? And other one is called Bohr-Einstein, okay, condensation. So here, these are the 5 types of particles, okay, based on the physical properties. Based on the chemical properties, we have pure substances. Okay, pure substances, or impure, and instead of that we can say mixtures. What they are called? Mixtures. Okay, pure substances and mixtures. Pure substances, again, they are classified into 2 types called as elements, okay, and compounds. Elements and compounds. Okay, elements again classified into like metals, non-metals, okay, metalloids, and noble gases. Okay, noble gases. And mixtures. Here mixtures classified into 2 types called as a homogeneous, and second one is heterogeneous. Okay, so like this all type of classifications of matter. So see, once again, just briefly I'll discuss and then we'll go to the actual topic. So here matter is what? Anything, any substance which has mass and occupy the space is called matter. Matter can be classified based on 2 ways. First one is based on physical states and second one is called a chemical combination. Based on the physical states, matter is classified into solids, liquids, gases, along with the plasma and Bose-Einstein condensate. Okay, Bohr-Einstein condensate. And whereas the chemical composition, they are classified into pure substances and mixtures. Pure substances are classified into again elements and compounds. Elements again classified into metals, non-metals, metalloids and noble gases. And here this side mixtures are classified into homogeneous and heterogeneous. Right, students? So this is a classification of matter. In this chapter, in this lesson particularly, what you are going to study? We are going to study about only about the physical states, but not about the chemical states. Okay, so that's what. Once if you want to note down this, you note down. Today means in this class we are going to discuss only about the physical state. About the chemical composition we discuss later. Okay, so the later classes or in the next year. Okay, when you go to the 7th class. Clear? So if you want to note down, note down. Chalo. Now, since I am going to rub this on chemical combination, chemical based on the chemical composition, this we are not going to discuss now. So that's what here I will remove this all. Okay, so this all I will remove, and okay, let it be. Afterwards, this also I will remove. Meanwhile, let it be here. Now, so here matter is classified based on the physical state. The 5 types: solids, liquids, gases, and plasma, and Bohr-Einstein condensate. Right. Now, what are the solids? You know. So, what is this? Is this a solid, liquid, or gas? It's a solid. Right. Now, if you take, for example, I have a, yeah. So, can you see what is this? This is an ink bottle. Okay, marker ink bottle. Now, in this ink is there. Okay, what is here? Ink. Okay, here ink is there. Right. Now, is this ink? Is it a solid, liquid, or gas? Yes, students. Is it a solid, liquid, or gas? It's a liquid. Okay, the ink comes under water, liquid. If I can take like this and I can drop. Okay, it's not opened, it's new one. Okay, so here that is a liquid. Ink is water, liquid. And then come to the gases. What are the gas? You know that air is a gas. So matter exists in 3 states: solids, liquids, and the gases. This you have studied. Okay. Apart from this, what are there? Plasma and Bohr-Einstein condensate is there. Right. That I'll discuss now one by one. Now, so here how we can understand the solids, liquids, and gases. So to explain the nature of solids and liquids and gases, here one theory was proposed. That theory is called kinetic theory of matter. What is called a kinetic theory of matter? So this I am rubbing, students, here. Okay, I am rubbing this one. I am not going to discuss about this one. So as I told you, okay. So kinetic theory of matter. What actually kinetic theory of matter states? So students, here kinetic theory of matter states that about the composition. Okay, first we see the composition. Composition means what? How a matter is made up of. So in the composition, first what it states is any matter is made up of a tiny particles. Any matter is made up of a tiny particles which are called atoms. Okay, which are called atoms or elements and molecules. So composition, matter is made up of atoms, okay, molecules, okay, or elements like this. Okay, so this is the first point. According to kinetic molecular theory, any matter is made up of composition. Composition is how it is made up of. Okay, so what is the composition of tea? For example, if they ask you, then what do you say? The milk, next sugar, next tea powder. Okay, so if these 3 mix together and boil it, you will get the tea. So what's the composition of tea? The composition of tea is how it is made up. The tea is made up of. So the tea is made up of these 3 things. Okay, so like that, how the matter is made up of? Matter is made up of like atoms or molecules or elements. So that's the kinetic theory first point. So first point of the kinetic theory states that any matter is made up of tiny particles, which will be atoms, which will be elements, which will be molecules. Now second one is about the motion. About the motion. So students, here the particles, any matter is made up of particles. Okay, So how these particles will be in that matter? Whether the particles will be rest or in motion. So the kinetic theory states that the particles of matter generally are in motion. How they are in motion? Okay. So the particles in the matter are in motion. Okay, but we can't see that motion. For example, if I take this solid, okay, this solid is made up of a tiny particles called tiny particles. Now, if I see, can I see any motion in this, any movement in this pen? No. Yes, but actually these are very microscopically, means microscopically. Here, the particles which are present in the matter, they will be in a motion. So the motion may be any type. Okay, it may generally motion, you know about the motion, three types are there. There may be translatory motion, which is moving in a straight line, which are vibratory motion, which are vibrate, and rotatory motion, anything. Okay, so here this generally the particles in the matter are in continuous motion. Okay, the particles in matter or in continuous, very important, or in continuous motion. Okay, so the particles in the matter are in continuous motion, continuously they will be moving, and the motion of the particles. Okay, third point, let us see. The motion of the particles, third one, depend on the temperature. Depend on the temperature. Okay, so depend on the temperature. So I am writing that is kinetic energy. Okay, kinetic energy. Kinetic energy means what? The energy possessed by the body, by an object, due to its motion is called a kinetic energy. The energy possessed by an object due to its motion is called the kinetic energy. Okay, so now object is moving when it is in motion. The meaning is it has some kinetic energy. Okay, so the particles in motion, so particles in the matter are in continuous motion, means they are in motion. So they have the kinetic energy. And whether this kinetic energy remains same? No. Kinetic energy depends on the temperature. It depends on the temperature. If the temperature is more, the motion is more. Okay, the temperature is less, the motion is less. And motion is directly proportional to the kinetic energy. Okay, for example, you see, if you take the milk, okay, normally the cold milk, under normal temperature, you see, can you see the many movement of the particles in the milk? No. But if you heat, if you boil, then automatically see the continued motion. Okay, the boiling means water, the milk particles are continuously moving. So why they are moving? Because we are provided the heat energy. Okay, so this energy is making to move these particles, right? So here kinetic energy means what? The energy possessed by the particles or object due to its motion is called kinetic energy, and the kinetic energy of the particles here is directly proportional to temperature. Means what? Is depends on the temperature. Means what? As the temperature increases, the kinetic energy increases. The kinetic energy is increasing means what? The motion of the particles is increasing. Okay, that's the third point. Now, fourth one is what? Here you see this matter is there. This is made up of tiny particles. So, these particles are not moving. They are closely packed. Okay, you might have studied in the solids, liquids and gases. No, in the lower classes somewhere. The solids, all the particles are very closely packed. In liquids, some loosely packed, and gases, there is no force of attraction, they can move randomly. Is this clear? So why they are closely packed? All the atoms, why they are very close to each other? Because there is some force of attraction between the molecules. Okay, the fourth point explains about the force of attraction. Force of attraction. So here the force of attraction is present okay, among the molecules in the matter. Among the molecules in the matter. And these forces are of two types. How many types? Two types. One is called cohesive force. What it is called? Cohesive force. And second one is called adhesive force. Adhesive force. So, the two types of forces are present in the matter. Okay, means among the molecules there are two types of force of attraction is there. Okay, there is a force of attraction. So all are coming close to each other. Okay, so that force of attraction is of two types. One is called cohesive force, second is called adhesive force. What is cohesive and what is adhesive? Students, here cohesive force means what? The force of attraction between or among the similar type of particles. Similar type of particles. For example, if you take water molecules, in one glass you take the water. So this water is made up of so many millions and trillions of water molecules. All these molecules are together in the glass. Why? Because there is some force of attraction. So that force of attraction which exists between these water molecules is called a cohesive force. It's called cohesive force. With the force of attraction between one water molecule and other water molecule is called a cohesive force. So both are water only, means the same type of particles. If the force of attraction present between two similar type of, means same type of molecules or particles is called a cohesive force. Adhesive forces means what? The force of attraction between two different type of molecules, Okay. For example, if you are taking the water in a glass, here the force of attraction between the glass and the water molecule. Okay. Glass also made up of, glass is also matter. So matter consists of molecules. So glass is also made up of some molecules. But the molecules of gas and molecules of water are different. These are not same kind. If the what is the force of attraction exists between the glass molecules and water molecules is called adhesive force. What is called adhesive? Adhesive means what? The force of attraction between two different type of molecules is called adhesive force. The force of attraction between two similar type of particles is called the cohesive force. Okay, so that's about the force of attraction. Is this clear to you? Now, next one is right. So these are the important points of the kinetic theory. Achha, one more intermolecular space also we can see. Intermolecular space. Intermolecular space. What is intermolecular space? The space between the two molecules. Here one molecule is there, here one molecule is there. Okay. For example, you see here that okay. If I take the solid, generally you see students here. If I take the solid, this is, you think this is a solid. Okay. The solid, how the molecules are arranged? Molecules are closely packed. No. So here. So here these are solid. In liquid, how the molecules are present? Just loosely. Okay. So how can you take, for example, if you take the beaker and there's some molecules, water molecules. If you take, I'm drawing like this, and if you take one room and if you take the gas molecules, this is one closed room. You think, just imagine, it's a closed room. Okay. So, in this, how the gas molecules are present? Like this. So, here, these atoms are very closely packed. Means what? The intermolecular space in the solids is very less. Intermolecular space in the solids is very, very less. So, molecules are like this, closely packed. Okay. So, like this, they are closely packed with each other. Okay. The space is how much? The space is very less. Okay. So, the intermolecular space means the distance between the two molecules is very, very less. Okay. And the liquids is a little far. So, little far. Okay. So, the intermolecular distance between the two water molecules, means liquid molecules, is little far. Okay. And if you see the gases, one is here, the intermolecular space between the two gas molecules is long. So, students, here, if the intermolecular space is small, the meaning is what? The force of attraction is more. Okay, the force of attraction is more because they are strongly attracting. Okay, So when the strongly attracted, the force of the space between them will be decreases. So here the force of attraction intermolecular space are inversely proportional to each other. Inversely means what? If one increases, other decreases. Right? For example, the force of attraction increases, then the space between the molecules will be decreases. So here see space between the two molecules is very less. So here the force of attraction is more. Here the comparatively here to this one, the intermolecular space, the space between the two molecules is increased here. Okay. So the force of attraction is decreased, less force of attraction. Here you see the distance between the two molecules is very high. So the space is increased, means what? The force of attraction is negligible. So as the force of attraction increases, the internuclear space decreases. If the internuclear space is increases, the force of attraction will decrease. Clear? So this is about the important points of the kinetic theory. So kinetic theory of matter, what it states about the composition, how it is made up of. It explains about the motion of the particles, how the particles moves in the matter, and it explains about the kinetic energy. So what the energy possessed by the particles when they are moving, and force of attraction, how the particles will be in solids, liquids, and gases some time, and intermolecular space, what the space okay between the two molecules. So this is all we have. Okay. So this is about the kinetic theory of matter. Understood? Any doubt? Okay. Now let us see the next topic. Okay. The next topic is here difference between solids, liquids, and gases. Difference between solids, liquids, and gases. So the difference between the solids, liquids, and gases are what? This topic. So first, if you come to the shape. Okay, if you see the shape, okay, solids have definite shape. For example, you see, this is called a cylindrical shape. This is a solid, have the cylindrical shape, right? And here it is duster. Okay, so otherwise I'll take one book. Okay, so this you see here, this is cuboid shape. So here see length, there's a length, there's a breadth, and it is a height. Okay, it's a cuboid shape. So when you take any matter, generally if it is a solid, it will have the definite shape. Okay, the shape is definite. Definite shape. Okay, the shape is what? Definite means what? Fixed shape is there. Definite means what? Fixed shape. Okay, so the shape is definite. Fixed. Liquids do not have a fixed shape. Why? If you take the liquid water, if you pour in the glass, they looks like they occupy the shape of the glass. If you pour in the jug or mug, it will occupy the mug. If you pour in the like pot, it is taking like a sphere. So they do not have the particular shape. Okay, there is no definite shape. Here also no definite shape. They have the shape of the container. Okay, they'll have a shape of what? A container. So that is about the shape. And second one, you see the mass. Okay, so then you see the mass. Otherwise, you take volume first. Volume. Okay, so solids have the definite volume. So they have the definite volume, fixed volume. Liquids also have a definite volume. How can you say the definite volume? When you go to purchase the milk, okay, when you go to purchase the milk, okay, then how much milk the shopkeeper asks you how much milk you need. Then what you can say? I want 1 liter or 2 liters. Okay, so liter indicates here what? Volume. So liquid have a definite volume, but gases no, they do not have any definite volume. Okay, then come to the mass. Okay, all will have the mass, all will have the definite mass. Okay, and then you see here force of attraction. Okay, this is discussed about the compressibility. When you see the compressibility, what is the compressibility? Compressibility means what? For example, if you take something, if you apply the force, then what happens? They become compressed. Okay, so that is called as a compressibility. So compressibility means what? For example, if I take the solid, so this is a solid. Now I'm pressing it, I'm applying some lot of force on it. Does it changing its shape? No. So the compressibility, no compressibility. Okay, it do not compress, whereas liquids also generally they do not compress, but maybe very slightly. Okay, very slightly they may compress, and liquids easily they compress. Okay, so they compress, right? Then fluid means flow. So here solids cannot to flow. For example, if I take the duster, okay, if I put the duster here, does it flow? No, it will not flow. It stay here only. But if I take the liquid and if I pour some liquid, so would they stay here only? No, it will flow, and gases also will flow. Okay, and already we discussed here the force of attraction in the solids is more, liquids is little less, and gas is negligible. Intermolecular space, here it is less, here it is normal, here it is more. So these are the properties of solids, liquids, and gases. Clear, students? So these are the properties. You have to remember about these properties, very important topic. Okay. So here, out of this 5 solids, liquid, gases, plasma, and Bohr-Einstein condensate, we will discuss about the 3. Okay. Now, here 2 more are there. One is called plasma, and the second is called BEC. Okay. So now here, what are these? Okay. So I'll discuss about these one also now. What is plasma? See, students, here, if you have a solid, this is a solid. Okay. You know that solids, if we on heating, they melts, okay, and they convert into liquids. They convert into what? Liquids. On heating, solids get converted into liquids. Still on heating, liquids can be converted into gas, okay. And gases on heating, what happens? Gas on heating, what happens? Okay. So you know that, for example, if I take the ice, example I am telling, ice, okay. If I take the ice, what is the state of the ice? Solid. If I heat the ice, then what happens? It turns into liquid, water. If I boil the water, what happens? It turns into gas. Still, if I heat it, then what happens? That stage is called the plasma stage. That stage is called what? Plasma state. Okay. So, students, here what happens actually? Any matter is made up of tiny particles called atoms. This I already discussed. Alright. So here atoms consist of still some particles inside. What are they? Electrons, protons, and neutrons. Electrons, protons, and neutrons. 3 types of particles are there. In that, electrons are negatively charged particles, protons are positively charged particles, and neutrons are neutral. Okay, means no charge. And one matter, means one atom, if you take, that atom generally it consists of same number of protons and electrons. Electrons and protons will be same. Electrons are negative charge, means minus charge, and protons are positive charge, means plus charge. Now same number of negative and positive charges are present in the atom, so atom is neutral. Neutral means what? No charge. Right? But students, what here happens? When we heat it, so solid is converted into liquid, liquid is converted into gas. But the gas also, the atoms, their state present in the atomic state, means in the presence of atoms, right? So they consist of electrons, protons, and neutrons. Now, further I am heating this gas, On heating gas, what happens? That gas starts now like dissociating. Dissociating means what here actually? That from that electrons will be coming out. Okay, that atoms or that particles, electrons are coming out. Electrons comes out. When electrons comes out, electrons are what? Negatively charged particles. So electrons are coming out. Okay, when electrons are coming out, now what is left inside? Positively charged. Okay, what is present? Positively charged nucleus, or you can say positively charged particle is left. This positively charged particle, okay, are called ions. What they are called? Ions. Okay. Generally, if it is neutral, we can say that is atom. On heating, what's happening? Electrons are coming out. And the electrons are coming out, they become neutral. Electrons are coming out, they become positively charged. These positively charged particles are called ions. Okay. Now, this process is called ionization. Ionization is what? The process of taking out the electrons, or the process of making the neutral atoms into ions is called the ionization. So, now when the electrons is coming out, these electrons and this positively charged electrons are neutral, and this positive charge, these are called ions. These both coexisted. Coexist means what? They existed together, like, okay, electrons and this ions, okay, positive charges coexist. So that state where these electrons and ions coexist, such state is called plasma state. What is called a plasma state? You can give any examples, like, nowadays we are using the LED TVs, no? So LED and OLED, these TVs are using. Okay, just a few years if you go back, like just 5-6 years or hardly 10 years back, then there was some plasma TVs. Plasma TVs were there. So the principle of the plasma TV is this only. Okay, so this is the plasma stage. So plasma stage is nothing but when solid is heated into liquid, liquid is on heating, it is converted into gas, gas is still on heating, so the electrons comes out, then the positively charged ions are formed. So these ions and electrons get coexist. So that stage where the ions and electrons get coexist, that is called the plasma state. And naturally this plasma state present in stars like sun, very high temperature and the sun and the stars, So in the stars, you can see the plasma state, right? So that's about the plasma. Okay. Now this is about the plasma. Then come to the Bohr-Einstein condensation. Bohr-Einstein condensation is nothing but, students, here the low denser particles. Okay, the low denser particles, when they are ultra cooled, when they are ultra cooled means what? Here normally water is normal temperature. Now you see the temperature might be 25 degrees Celsius or 30 degrees Celsius. Here the water exists in liquid state, right? Now if I reduce the temperature, means if I put in the refrigerator, then what happens? After some time it becomes ice, means what? Where the temperature becomes 0, 25 to 0 degrees Celsius reduced, then that becomes ice. Ice is what? Solid state. That is normally, that's cooled. Okay. Now still if I cool, like you could go to the ice cream shops, okay. So there is a refrigerator there. In that, if you take the ice cream, you can see smoke lights looking like a smoke is coming. So there the temperature will be like -20, -30 degrees Celsius. How much it is? -20, -30. That's also cool. But here ultra cooled means what? The temperature will be very, very less. -100s, -200. Okay, like we can go up to 0 Kelvin. 0 Kelvin means what? -273 degrees Celsius is called. -273 degrees Celsius is called 0 Kelvin. So such a very low temperature, if you go, then what the particles we can find, what the state of the particles we can find, that is called Bose-Einstein condensate. What is the Bose-Einstein? Why the name is given Bose-Einstein condensate? So here, this phenomena, initially explained, by our Indian scientist in the 1920, Satyendranath Bose, Satyendranath Bose, who first time this concept he introduced in 1920, means what? 100 years back. Okay, now we are in 2023. So 1920, here Satyendranath Bose proposed this concept, and it was Einstein also, he supported this theory. So based on the names of these two scientists, Satyendranath Bose and Albert Einstein, so this state of matter was named as a Bose-Einstein condensate. So that's about them. And the first Bose-Einstein condensate particles, state of matter, was achieved. They were proposed. Satyendranath Bose and Einstein, they proposed, means they explained, but they didn't do it. Okay, but that was first time this state of matter was achieved by the two scientists called Eric Cornell and Carl Wayman. These are the two scientists in 1995. Okay, so the first time they made this state of matter, and for that they also received the Nobel Prize. Okay, so that's all, students. So that's all about the states of matter. Clear?